All right. Hello, everyone. This week, I'm excited to have Patrick Clark with us. Patrick is a technical artist. He's worked in the game industry for a number of years. We were fortunate enough to have him on my team at Wayfair Next. And I brought him here today to talk shop about photogrammetry and other 3D scanning technologies. Patrick, let me throw it over to you for you to give your intro.
Awesome. Thanks, Mike. I'm Patrick Clark. I'm currently the lead environment artist at Azure Games, working on Project Legends, a sword and sorcery inspired game for mobile and possibly PC.
Nice. Very cool. Yeah. So, Patrick, back in the day, I think we first met probably around 2015, maybe 2016, somewhere in that, almost a decade ago, which is kind of hard to believe at this point. Um,
Yeah.
and I know you can't talk too much about, your work at Rockstar Games, but I do know you have done, some impressive stuff in the past, especially when it relates to photogrammetry. And, maybe just give us a quick background about how you got into photogrammetry to begin with, and then maybe I'll do a primer about what it even is.
Sure, yeah. So I primarily got interested and involved in it when I was at Rockstar Games. Before that, I had spent a number of years, dabbling in photography. My grandfather was really into photography. He had his own dark room. He processed his own photos in his house. Won numerous awards for photography.
Oh,
So I
wow. I
always
didn't notice that.
had kind of that photography bug. Uh, Once we started to hear about this new kind of technology called photogrammetry, being used for games. We obviously wanted to check it out. I'm very curious. Company like Rockstar always wants to be at the forefront of technology, trying to create better content faster, cheaper. Uh, yeah, so a lot of my early exploration was while I was at Rockstar Games to improve their games.
Awesome. Yeah, it's always cool to see, leading companies like that investing in new technologies. At Wayfair, it was kind of a little bit random. Like, we had the opportunity basically through this initiative called Wayfair Next to explore emerging technologies. And photogrammetry is kind of one of the early topics that we kind of delved into. And I think this is probably a good chance for me to inform the audience, especially those who've heard of photogrammetry, but they don't really at a deep level understand how it works or what it is. Because to me, when I first discovered it, and maybe same for you, Patrick, but it felt like magic. Is like, oh wait, I can just take a couple photos from different angles, and somehow the software is going to turn that into like a 3D photo. And effectively, what you're doing is, it's similar to our eyes. Like, you get depth perception because you have two different points of view. The camera is essentially doing the same thing, and the software is looking for different feature points to overlap so that it can figure out, from this perspective, I see these colors. This perspective, I see these colors. And by figuring out how far apart they are in space, you can basically create a 3D pixel. Usually call that a point cloud. We'll talk about maybe some Gaussian splats, which are related. But yeah, I don't know, Patrick, you want to add anything else to, like, just simple, like, what is it is?
Yeah, well, interestingly enough, photogrammetry, the fundamentals predate photography by quite a
Oh,
bit,
wow.
um,
Yeah.
dating back to the 1400s when Leonardo da Vinci developed the principles of perspective and projective geometry. So it's actually been around a lot longer than our cameras have.
Oh,
Which
wow. That's amazing. I didn't know that.
Photogrammetry, it's fantastic. It's gained a ton of use across e-commerce and games and film and VFX, and now it's kind of evolved into these new technologies that we'll talk about later, NERFs and Gaussian splats. Yeah, it's still one
Excellent. Yeah.
everywhere.
Yeah, I think one of the cool things about it too is it's pretty accessible, especially
Mhm.
these days with smartphone cameras getting as good as they are.
Yeah.
Back when we were at Wayfair, we invested in, DSLRs and nice lighting and a more professional setup. And I still largely use that same workflow today for really high quality scans. But the cool thing is, like, everyone's got a smartphone in their pocket that is, essentially capable of capturing pretty decent photogrammetry. There are apps that'll kind of do it for you directly in the app, or maybe a little more traditionally, you capture your photo set, import it into the PC or Mac, and then kind of do a little bit of software editing. I use Agisoft. That's kind of one that's been around for a long time, but there's numerous software packages out there. Do you have a preference or a favorite one, Patrick?
I still like to use Agisoft Metashape. I do on occasion dabble with RealityScan. It is now owned by Epic Games. They
Mhm.
spend quite a bit of time and energy in promoting photogrammetry and a lot of these tools for game developers and film and VFX. Polycam is also a great one. I really like that one for mobile.
Mhm.
They say the best camera is the one that you have, and a lot of
Yes,
people have cameras in
true.
their pockets now, which is fantastic. So even when you're out and about and you see something interesting, you can scan it right then and there. You don't have to worry about having a big camera on you.
Yeah.
Interestingly enough, Scanaverse, which is made by a company called Niantic, and
Mhm.
some people might recognize that company as the makers of Pokemon Go. They have an app there as well. So there's lots of great
Yeah.
options.
And as we talk about Gaussian splatting a little bit later too, that's my go-to tool for recording splats like on the go. But
Awesome.
yeah, I think to your point, being like able to capture this stuff anywhere is really powerful.
Mhm.
And I remember, again, dating back about 10 years ago, after first discovering this, I feel like every time I'd be somewhere, especially with interesting architecture, I'd think about it from like a technical perspective of how could I capture a good scan of this. One of the things that's interesting and maybe challenging, but that's why I find it interesting, is that photogrammetry doesn't actually work well on all material types or surfaces. Maybe you want to tell us a little bit about some of the challenging objects, materials, and maybe some things that you've scanned in the past that are maybe on that hard scale of spectrum.
Yeah, so generally, photogrammetry doesn't work well for things that move in between the photos, like people. People can be really challenging. Even when you're trying to hold really still, you're actually moving quite a bit. People have a lot of micro movements. Things that are highly reflective and shiny, cars, especially brand new ones, are pretty challenging. Things with really small, fine detail, like hair, Christmas trees, are
Mm.
also very difficult. Anything that's a little transparent, like windows as well. There are a number of techniques you can use to get around that. You can do a few things around cutting out some of the light using polarizing filters on your camera, or they now have dedicated sprays for scanning, which was not really a thing when I first started into photogrammetry. We had to kind of find our own off the shelf sprays,
Yeah, I know
things like
foot
using
powder has
foot
always been
powder.
kind of a
Yeah,
good one. Yeah.
that was a popular one. Yeah. Uh, there's
Yeah, you're
also, a
essentially
bunch
trying
of
to
other
dull it
things there.
down, right? So, like,
Yeah.
the fundamental challenge, I think, is that from different camera angles, certain reflections and highlights are not gonna react in the same way that as a
Mhm.
piece of wood or something that would be fixed and easy to understand from multiple angles. Those are great for scanning, and then once you add that kind of, like, layer of reflectivity or sheen or especially, like, the car paint, from each angle, let's say like the sun is highlighting it in one area, and then from a different camera angle, now it's highlighting it in a different area. And so you often end up in your reconstruction getting all this kind of bumpiness or even holes or weird surfaces.
Yep. People are also quite challenging, but also highly requested for film, VFX, and now games as well. And to
Mhm.
do that, you typically have to build like an array of cameras, anywhere from 40 to I've seen upwards of 100 or even 200 cameras that all shoot simultaneously. I've built a smaller rig, numbered in about 40 plus cameras when I was at
That's still
Rockstar.
pretty good
Yeah.
size. Yeah.
Yeah, there's a lot of technical challenges that come with that, but you need to do that to be able to actually capture and scan people appropriately.
That reminds me, we did. You remember? I'm pretty sure you were on this outing at Wayfair. We went to visit a studio downtown Boston that
Yep.
had at least 100 plus cameras, and they were primarily using it for wedding toppers. That was kind of their main business. People
Yeah.
would come and then they'd pose, stand in the middle of this giant sphere of cameras, and the cameras are all synced, so you can capture that still image without worrying about people blinking or twitching or moving between individual shots. If you're trying to move a camera around, to your point, it's like almost impossible to get a good scan. But they seem to do a pretty good job. And I remember they
Mhm.
scanned some of us, and they didn't do the 3D print, but that was the other part of their business was, oh, we can 3D print it, a
Yeah.
little miniature desk figurine for yourself or your pets or, your kids. And, so they had a little business going there. I should look in to see if they're still around or what they're doing these days.
Yeah, there's a lot of interesting use cases for capturing people. I know there was a professor at UMass Amherst who built small rigs to scan animals. In fact, he called it the Beast Cam, which is really
Yeah.
interesting and not something
Yeah,
you see,
that's
too
Duncan. I
often.
should get him on the show one of these
Yeah,
days too. They scanned a shark and all
yeah.
kinds of crazy stuff.
I've scanned a taxidermied alligator, but never a live one. He's done the real thing, so I think he would be a great person to come on and talk about his adventures and his R&D around it. He's got a lot of
Yeah.
cool stories.
Yeah, that's awesome. Cool. Well, we've hinted at it a few times now. I'd like to
Mhm.
maybe start delving into some of the newer stuff that's out there these days, right? So photogrammetry has been around for a
Yep.
while. One of the intermediary steps in the photogrammetry process is a point cloud, which
Yep.
we were kind of saying is that 3D, spatial pixels. And then from there, in traditional photogrammetry, you turn it into a triangular mesh, and then you kind of project and paint the texture back on. But there's a new technique on the block, or a couple new ones, right? There's kind of NERF and then Gaussian
Mhm.
Splats. Maybe you want to tell us a little bit about what those are and why you're excited about them?
Sure. So nerfs, while incredibly cool, were very short-lived because they were pretty much replaced by Gaussian splats. But nerfs are not the small little toy that you buy in Target. Uh,
To play out
they're
the guns.
it's short for neural radiance field, and it's a similar volumetric representation of a scene, and that means that there's no spaces or gaps between the points, sort of like a 3D mesh. The very interesting and big advantage to those is that they can still infer geometry from reflective or transparent objects in scenes, and things that don't have contours like the sky, where photogrammetry would not give you really much of anything. You might get
Mhm.
some
Yeah.
good points in the point cloud, but you're not going to get a good mesh from either of those things. And so nerfs very very nicely solve that kind of problem. Uh,
Yeah, so that's interesting. So you can get a mesh out of that as well. So maybe if you're
yeah.
trying to do some physics or interaction or
Mhm.
simulation with it, that's interesting. Because a traditional photogrammetry mesh, one of the benefits of working in kind of triangles and textures is it's well understood by the gaming industry and just software in general these days handles and can process lots of triangles and lots of textures. GPUs are kind of optimized for it. And then we start getting to these newer technologies. It's like, well, sometimes you gain, some things, but then you also lose others. And as we get into like Gaussian splats, that's one that maybe has a challenge of underlying physics and geometry
Mhm.
and meshes and maybe reanimating it or relighting it. However, it does capture a scene in an interesting way. Do you want to tell us a little bit more about splatting and that technique?
Yeah, so Gaussian splats have, for the most part, kind of been the newest kid on the block, as they say, and it's kind of followed suit from NERFs and photogrammetry. And Gaussian splats are basically images that are converted to Gaussians, which is basically just kind of like a little blob of color. I guess one of the best ways to kind of think of it is if you crack an egg on a frying pan, and if you're like me, you always accidentally break the yolk and you start getting the yolk, it kind of spreads out. It's an
Yeah.
oblong shape on the pan, and the strongest color is in the center, and then it slowly, kind of fades out towards the edge. And so a Gaussian splat is just an entire scene made up of millions of these little oblong shapes with very intense color in the center, and it looks very realistic. It's quite literally, looking at millions of little like these blobs of color that looks creates highly realistic spaces. And the advantage over nerfs is that it's very quick to move around. You don't have to wait. It's highly interactive in that you can move around the space really quickly. Um,
Yeah, and we can capture these now, like you were saying with Niantic, for
mhm.
example. Like their tool allows you to basically walk through a space in real time. You can see the point cloud kind of refining itself, and
Yep.
then after you can process it on the device. And just to not get into too much detail, but the processing is interesting because it's kind of a reinforcement learning with AI where it takes like one camera angle
Mhm.
and it like basically it looks at all these splats that were generated and it starts to kind of stretch them and pull them and color them in a certain way. And then it takes a different camera angle and it basically uses that same set and then it starts doing the same thing to that one.
Yeah.
And it loops through, dozens of times to go through all those camera angles again. And each time it's kind of tweaking some of the parameters. And yeah, if you look at like, zoom in on some of these splats, you'll notice, especially thin features, they kind of like are stretched and elongated.
Yep.
Where it's interesting because you can represent things like a Christmas tree, right? Like we were
Mhm.
saying, would be hard to do with photogrammetry because you'd have to draw triangles for each of those little points. Whereas here you're kind of getting almost like stretched out and like virtualized points.
Yeah, and you make a good point about upgrading the point cloud and the data. And that one of the big advantages there is that you can also mix multiple data sources fairly easily, like photos from cameras or drones or cell phones. You can put together, a Gaussian splat with all of those sources. Whereas with photogrammetry, you're going to get a bit more, you're going to have more of a difficult time, getting a good result from it.
Mhm. Yeah, photogrammetry, I feel like you really have to control the environment, the
Yep.
lighting. We mentioned techniques like cross polarization. So you put on your special filters, you try to reduce some of that like reflective light, but keeping everything kind of uniform,
Mhm.
doing the color correction. I feel like it can be a great, reference point, and the mesh sometimes can come out perfect depending on the product's, materials. If it's like a wooden thing or a statue, like those usually come out great. If it's, transparent glass, then, not so much. Maybe with a little of the spray, you can capture the shape. But typically, we find when we create content through the photogrammetry pipeline, is it can provide really great reference data, but not really usually usable mesh right out like automatically, as maybe folks expect or think like, oh, it's just
Yeah.
going to give us all the work, no artist needed. In reality, there's still a lot of kind of manual touch up to be done. But in the end, I think the result you can get from it is probably the most realistic looking, 3D traditional mesh, right? If you're created through photogrammetry or scanning, versus if you're just drawing it from reference photos.
Oh, for sure. Yeah. At least at current time, there's a lot of tools that leverage the mesh, created by photogrammetry,
Hmm.
film, games, TV. They all use those meshes, for various purposes. And as you touched on briefly earlier, even if the mesh at the end is not perfect, you're getting a lot of data, a lot of photographs of things that are still highly valuable.
Hmm.
And
Yeah.
thanks to the rise of AI and machine learning and a lot of advancements there, you can do a lot with just a couple photos now. One good example is selfies from your phone. If you don't have a really awesome, photo studio in your own home, how many people do? You can take
Mhm.
a selfie, and most phones now will let you relight that picture, and that's because phones have 4 or 5 cameras, sometimes even more now, and they're doing a very rough, photogrammetric like model on the fly, uh, and they will allow you to relight that photo to make it look like you're taking your picture in a photo studio, even if you're just sitting in your office like I am now.
Yeah, no, I agree. I think it's amazing, like, a lot of these kind of AI powered tools that
Yep.
folks are able to leverage, maybe not even realizing what's happening.
Hmm.
It's just like, oh, I'm going to put on portrait mode, and oh, now it looks nice. The background's kind of blurred, and
Yeah.
behind the scenes, the technology is, applying similar techniques to what we've been discussing. As we think about that, like, are there other, I don't know, emerging or interesting ways of capturing, 3D scenes or 3D data that you can think of, or is splats kind of the main thing these days that everyone's focused on?
Right now, it's largely trying to, leverage splats in more meaningful ways. I think one of the big drawbacks is that they don't really create a solid mesh, and all of the technologies that currently exist really like to use meshes. And
Mhm.
so there's a lot of research in, well, how can we better use these splats because they're so much easier to produce. Um, a lot of efforts around reducing the size of them as well. They can be pretty hefty in terms of storage. Uh, yeah, so
Yeah, I
most of
believe, like,
the yeah,
Niantic created a new, like, format, like, to
yes,
stuff that data in and try to, compress it. I think they were saying it was about, like, a 10x size reduction versus, like, POI, which is kind of an older format. People are
yep.
just sticking their point cloud data in there, spherical harmonic information, which
Mhm.
kind of affects the color depending on your angle. But, yeah, I think, there's still research to be done, right, to get these to maybe be a little more web friendly.
Yeah.
And, yeah.
Yeah, and people are still trying to find really, great use cases for it. It's still pretty new technology, relatively speaking. Um, yeah, for the most part, it's a very fancy point cloud, which we've had for a while, but now they obviously look, so much better than, a typical dense cloud or point cloud.
Yeah,
And,
instead of
and they're
having just
very
like a
exciting.
physical single sphere in one place, it's now this like
Exactly.
basically this split that's view dependent color and like kind of stretchy
Yep.
opacity. It kind of reminds me a little bit of like the Photoshop like opacity brush where you can,
Yes.
dial it in to be
Exactly.
soft or hard edges. And yeah, looks pretty interesting.
Yep.
Cool. Excuse me. One other, game related technology that is out there and interesting gaining traction is Nanite in Unreal Engine
Mm.
5.
Yep.
Have you had a chance to work with that much, or, do you want to, talk about that a little bit for the audience?
Yeah, I dabble with it in my free time. So Nanite is a new way of rendering introduced by Epic Games in their engine, Unreal. So Unreal powers the very popular game Fortnite and many other
Mhm.
games being made. So what Nanite does is it allows you to use very high resolution meshes, and with very relatively minimal, cost to render time. So you can put a lot of these high resolution meshes being that you produce from photogrammetry directly into a game, and it won't really impact the game performance a whole lot. There are still some drawbacks here and there. There's still some problems, but for the most part, you could go outside and scan, some rocks or trees and get meshes that are several million triangles, which is huge,
Mhm.
and put them right
Yeah.
into Unreal using Nanite, and the frame rate would be great. You would be playing, running around just like you're playing a game that you had bought off the shelf. Performance would be excellent, and so that's really helped, kind of bring photogrammetry back a little bit, in the sense
Mhm.
that now we can spend less time optimizing models. A lot of like post process kind of work, reducing them down. Now we can take some of these like source meshes that we get and just put them right into the game engine.
Yeah. Yeah, I
Yep.
remember, like, back in the day, Megascans, which was
Hmm.
eventually acquired by Epic, and now it's been integrated into Unreal. But I remember you telling me about them, waiting for
Yep.
it to come out, like, "Oh, these guys are making these, like, awesome, like, high quality scans. It's gonna be called Megascans." And it still took a couple years before it finally came out. And
Yep.
then, it's a pretty cool, like, source, and like I said, now it's integrated into a lot of, Epic's tool set. But, yeah, it's pretty crazy you can just plug this stuff right into, like, a game environment now
Mhm.
and not really have to deal with performance issues, and you still probably have trade-offs on file size, right? If you're going to
Yep.
have these
Oh
millions
yeah.
of triangles and high res textures, there's going to be a little bit of a, I mean, we've probably seen that, if you're a gamer like I am, and Patrick, like the download size now, like I remember Red Dead Redemption 2, which was one of the games you worked on, being the first game that crossed that 100 gigabyte download mark for me. And now it's like all the time. Like it's
Yeah. Yeah.
commonplace. And the default hard drive sizes like on a, PS5 or an Xbox are like small enough that you have to juggle your games now. And then if you want to re-download a game, it's like, oh, I have to think about that ahead of time and let it go, even on a fast connection. Sit around for 30 minutes to an hour to download these like hundreds of gigabytes of files. So I suppose that's maybe one of the consequences is the performance can run in real
Yep.
time, but the download is still gonna be a little hefty.
Yeah, there's still some drawbacks to it. There's still some things that it doesn't handle too well either. So for a long time, and even still to this day, most things like grass and trees are made with we call like alpha, and so it's just a,
Mhm.
a 2D picture of like a leaf, but you just don't draw everything around it. It's like a cutout of a leaf, and that was because it was really fast and cheap to render. Unfortunately, Nanite does not handle that too well, and so now we
Oh.
actually have to go back and rebuild a lot of our trees to just fully model the leaf,
Oh,
which
wow.
is kind of crazy to think about. Uh,
Yeah.
yeah,
I didn't realize that. So yeah, it's
yeah,
interesting, gaming, I think you told me this once, but it's always about like cheating, right? You're always trying to
yes,
find tricks to get it to draw something as realistic as possible with as little impact to the, GPU and CPU as possible.
yeah,
And yeah, techniques like alpha maps and stuff are, I guess that's interesting. They're
mhm,
going away perhaps as this new technology, and maybe even splats
yeah.
too. As you're mentioning trees, I was thinking of,
Mhm.
how splats can work pretty well for, foliage.
Yeah, there's a lot of new technology, a lot of stuff that's still largely unexplored. A lot of people are still trying to figure out how to best use it. And as always, it's people who are getting their hands dirty and being thoughtful about how they're using it and finding novel ways to connect technology to different use cases are going to find a lot of value there.
Yeah. So speaking of that, and as we kind of get close to wrapping up, I'm curious, like where do you find new techniques and sources? Like who do you follow? Like what are the maybe conferences or events that are the best to keep up to date with the latest?
I still follow SIGGRAPH, quite a bit. I haven't been
Hmm.
able to attend recently, but SIGGRAPH is pretty much my go-to. The Society for Integrated Graphics, and they're happening pretty much nonstop now. And with the pandemic, there's a lot that happens remotely now, which is fantastic because it's much easier to see presentations. As for individual people, recently I was introduced to an artist who used to work at Epic Games. His name is Christoph Schindelar, and I may be butchering his last name, and I apologize to Christoph. But he's fantastic. He's one of the best, photogrammetry uh, builders, users, designers, whatever, however you want to describe him. He does some really fantastic work. Probably, some of the most uh, advanced like scanning techniques, to create some really high quality stuff.
Excellent.
So
Yeah, we'll put a link in the description then.
yeah,
Make sure you get those out there. And I think SIGGRAPH's happening in Vancouver this summer.
yeah.
That's yeah. And then from my perspective, there's another group. I mean, I'm involved with Kronos. I think as we've discussed in the past. So Kronos is always promoting new technologies. Kronos is a little maybe more cost prohibitive for a lot of
Yep.
companies to participate in. There's another group though, the Metaverse Standards Forum, that's been promoting basically open standards for 3D technology. Metaverse is kind of the main focus, but in general, like we're a lot of technology folks that have been building and developing, 3D experiences across the board. And they recently had a, town hall for, Gaussian splatting, and there's going to be a sequel to it coming up, I believe, next month. So I can include a description in there. The nice thing about it is it's free to join. If you want to be a paid member to help support the group, there are, membership tiers, but they're, pretty reasonable. So yeah, again, another way to get involved.
Awesome. You're gonna have to send me the link to that. I will absolutely be signing up.
All right, I will do that,
Cool.
and we'll put a link in the description. Great. I think we covered most of our topics. Was there anything else that I might have missed, Patrick?
Uh, Man, we covered a lot. I think when people look at photogrammetry and they ask, why should I use photogrammetry, and I think there's probably three key things to consider. One is preservation, and that's images are knowledge, and that's preserving what we have for the future. The other one would be production, where images are entertainment, like games, films, VFX, and presentation, where images are commerce, retail, e-commerce, sites like Wayfair.
Yep.
And so photogrammetry, despite not being the newest kid on the block, like Gaussian Splats and NERFs, still has a ton of value and used everywhere. And with Epic Games' development of Unreal, it is now finding new life and is being needed, now more than ever, and finding a ton of room, to grow both in games and entertainment and in places like the Smithsonian and
Oh yeah.
online retailers.
Excellent.
Cool.
Yeah. Well, that's awesome. Well, again, always a pleasure, Patrick. Love catching up with you and talking shop. Hope you guys enjoyed this. Feel free to leave a comment, like and subscribe, all those good things, and we'll see you next time. Thanks.